Line L is given by the equation this, and point P has coordinates 6, -5. Explain why point P is not on the line L. So in order for a point to be on a line, that means that that point needs to satisfy the equation of the line, right? If it's on that line, that means that if I plug in 6 for x, I should get back -5 for y. If I don't, then this point is not on the line. So that's how you show or explain that the point is not on the line, is that if I plug in 6, -5 for x and y, it should give me an untrue statement. It should tell me like 3 is equal to -6, which is not true. So that's what we're going to do to show that something is on the line or not on the line, is if you plug that point into the line, it should give you either a true statement or not true statement, and that will tell you whether it's on the line. I hope that made sense. Okay, so I'm plugging in -5 for y plus 2 times 6 for x. It should give me 9. It's telling me right now that it's not going to, which means that it won't be on the line. So that's -15 plus 12. We can even put a question mark over the equal sign to say, I don't know, does it equal 9? -15 plus 12 is -3, which does not equal 9. So that means that the point 6, -5 is not on line L. Okay, we want to find the gradient of line L. And normally I would tell you, okay, the gradient or the slope is the number that's in front of the x value. But that is only true if you have it in y equals mx plus b form, which it's not. Right now it's in general form. So we need to get it into this form in order to find our m value, because 2 is not correct. So I want you to right now isolate for y, and then tell me what that slope is. If I have 3y plus 2x equals 9, I want to isolate for y. I first need to undo this whole piece right here, which means I need to subtract 2x from both sides. I'm going to put it over here, -2x plus 9. -2x is the same thing as subtracting x. I just like having the x in the front, and 9 is positive, which means it becomes a plus. Now I need to divide everything by 3. Y equals -2/3 x plus 3. If isolating a variable, in other words, getting a variable by itself, is something that's stressing you out and something you don't feel confident in doing, there is an additional help piece or example in your resources page that shows you or has like additional practice on isolating variables. That's something you absolutely need to know how to do. Okay, so our slope is now this number that's in front of x because it's in this form. So our slope is -2/3. Now we want to write down the gradient of a line that's perpendicular to this line. So the perpendicular slope would be what? Since it started off negative, now it becomes positive. So it's just the flipped sign and flipped fraction. It's a ton of flipping. So no more negatives. Now it's positive, and 2/3 becomes 3/2. And that's it. Find the equation of the line perpendicular to line L and passes through point B. So we have a slope. Our slope is 3/2. And now our point, x1, y1, is equal to 6, -5. Okay. All right, so we have a point and a slope, which means we're going to use our point slope form to write the equation of this line. We do y minus y1 minus a negative number becomes plus equals m times x minus x1. It does not tell us which form to put the equation in, so we can just leave it like this. If you would like to practice, or if you feel like you need to practice this, definitely go ahead and see if you can isolate for y on this guy in an appropriate way. But that's it for that problem. An architect plans a quadrilateral structure in the form of a parallelogram. The following 4 points are the vertices of a quadrilateral. Determine whether the quadrilateral is a parallelogram. What we know about parallelograms is mostly just that the opposite sides are parallel. And since we're talking about parallel versus perpendicular lines, this is a very IB question where it's saying, hey, show that this is a parallelogram, which means that we need to show that this line is parallel to this line. In other words, they have the same slope. And we need to show that this line is parallel to this line. In other words, they have the same slope. So we need to find the 4 slopes of each of those sides in order to determine whether it's a parallelogram or not. I'm going to first graph a visual representation. It's going to be a very sloppy graph. It's going to be what I call a poor man's graph, which is an American phrase for just like it's like a go-to, like just really quick, not the most fancy, but it does the job. Okay, so, I drew my axes, so everything is positive, and that is not the case. We have some negative values. So I'll draw my axes to better represent that. Okay, so negative 1, 3 would be, I don't know, somewhere like here, that's P. Negative 2, 5 is like here. 0, 4 is like here. Again, realize it's just a guesstimate here. And then 1, 2 is right here. We can see just from our poor man's graph right now that this is not a parallelogram, but we're going to show that by finding the slope of QM, and we're also going to find the slope of what would be the opposite of it, which is PN. Opposite because like they don't share any vertices, which means they're completely opposite of each other. So to find slopes, it is your change in your y's over your change in your x's. So go ahead and take the 2 points, Q and M, and find the slope. If we're subtracting our y values, that's going to be 4 minus 5. Do not do 4 minus 0 or 0 minus 4. You cannot subtract within the same point. It's between 2 different points, your 2 y values of 2 different points. And then your 2x values is subtracted is 0 minus negative 2. That's negative 1/2. Pn is then this and this. Go ahead and solve for the slope of Pn. Change in y's is 2 minus 3 over 1 minus, that's why. 1 minus negative 1 becomes plus 1, so that's negative 1/2. They are parallel. It's because I graphed this at negative 1, negative 3, which hopefully some of you were like, miss, that's totally wrong. This is what's going on. So that looks more like a parallelogram. So those 2 slopes are the same, which means that they're parallel. Now, in order to show that it is a parallelogram, I've proven that one set of opposite sides are parallel, but I need to prove the other side. It's because it could be a trapezoid, where these guys are parallel, but these guys are not. So you need to prove that both sets of opposite sides are parallel. So now I need to find the slope of QP and MN. Go ahead and find those on your own. For QP, that would be 5 minus 3 over negative 2 plus 1. 5 minus 3, negative 2 minus negative 1. So that's going to be 2 over negative 1, or in other words, negative 2. Not perpendicular slopes, but close. Since they're both negative, they wouldn't be perpendicular. Mn would be 2 minus 4 over 1 minus 0, which is negative 2 over 1, so negative 2. So since those slopes are exactly the same, now we've proven that both sets of opposite sides are parallel, which means that yes, P, Q, M, N is a parallelogram. Okay. Now we want to determine whether the diagonals are perpendicular. So now I need to find the slopes of the two diagonals and determine whether they're negative reciprocals of each other. The diagonals in this case are what connects opposite corners. So that would be a diagonal. This would also be a diagonal. So in this case, my two diagonals are QN and MP. Do this entire problem, last one, on your own. First, you need to find those slopes. So the slope of Qn, 2 minus 5 over 1 plus 2, negative 1. MP, one of them is negative, one of them is positive, and the reciprocal of 1 is just 1 over 1, which is 1. So 1 and negative 1 are negative reciprocals of each other, which means that they are perpendicular. This is true of any parallelogram. All of their diagonals will always be perpendicular. So, yeah, okay, good job. The number one thing I want you to take away from today is that if we're talking about parallel versus perpendicular, really we're talking about slope and the relationship of the two slopes. Then we can just use what we know about equations of lines to find the equation. But if you see the words parallel or perpendicular, I want your automatic thought to be, oh, I'm talking about slopes here. That's what I hope you take away from today. Good job.